we have all the factors of 27. That's it, right? This is once again a review of yesterday. Looking at question number 2 to number 26, the factors of 26 for sure are 1 and 26. Right? This always works. 1 is always a factor. Is 2 a factor of 26? Yes, 2 times what? 2 times 13, correct? Is 3 a factor? No, 4, 5, 6, 7, 8, 9, 10, 11, 12? No? Okay. Alright, so went to 12, because then 13 is already in the list. So there, we're done with the factors. Right, that was, once again, this first 6 questions is just a review of yesterday. Any questions on the first 6? Then, question number 7, it's also some review. It says, write the prime factorization of each. Do not use exponents. So we started this as a tree diagram. Give me any 2 numbers. We're trying to go with smaller numbers. Give me any 2 numbers that multiply equals 25. 5 times 5. Both are prime numbers, so I'm just going to write this as 5 times 5. Just write the prime factorization. If I look at question number 8, number 22, give me any 2 numbers that multiply equals 22. 2 and 11. Both are prime, so I'm just going to go 2 times 11. Right, if you can break it more, break it more. Don't use exponents. What I mean with that, for question number 7, don't go 5 to the second power. Right, don't use exponents. Just write it out, 5 times 5. So this, once again, this is just a review of yesterday. Any questions up until 12? 11? Alright, let's take a look at question number 11. Give me any 2 numbers. So again, we're trying to go smaller numbers. Any 2 numbers that multiply equals 20. 5 times 4, okay. 5 is prime, so I'm not going to be able to break it, but 4 is not. Give me 2 numbers that multiply equals 4. 2 and 2. So I'm just going to write 2 times 2 times 5. We try to list them from small to large. So that's why I wrote the 2's first. Okay, this thing just froze for a minute. Not only it froze, but it erased everything. Alright, so while we're waiting on technology to come back, so 20 we got 2 times 2 times 5, right? That's basically what we did. There you go. Right, any questions for the first 12? Alright, we're going to move into new stuff. Question number 13 says find the GCF of each. But if you notice, the title of the worksheet is greatest common factor. That's what GCF stands for. Greatest means the biggest, right? Greatest. Common, that it's in both, or it's in everybody has. And factor, what we've been talking about factors is. So greatest common factor, basically the greatest factor that is in this case in both numbers. That's what we're looking at. And there's 2 ways we can do this. 2 ways. I'm going to show you guys both ways. First way, write all the factors of 27. I'm just going to go 1 times 27, 3 times 9, and that's pretty much it. Right, I listed all my factors. For 18, I'm going to go 1 times 18, 2 times 9, 3 times 6, and I'm done. So my greatest common factor is the biggest number that is in both lists. In my case, 9. Okay, that's one way of doing it. Listing all the factors, and we're looking at which one's the biggest number in all of the lists. And I say all because it could be more than 2 lists. So that's 9. Another way we can do this, write the prime factorization of 27. It happens to be 3 times 3 times 3. The prime factorization of 18 is 2 times 3 times 3. I noted that they have in common in prime numbers they have a 3 and a 3. When I multiply them out, I get my greatest common factor, which happens to be 9 as well. So do it, making the list of all the factors, look for the biggest number in both lists, or write them in prime factorization, look what they have in common, and they have more than one factor, multiply those factors out. So that's one way. Let's take a look at number 14. If I look at this, the factors of 40 are 1 and 40, 2 and 20, 3 is not a factor, 4 times 10, and then 5 times 8. Right, those are all the factors of 40. If I look at the factors of 35, I go 1 times 35, 5 times 7, and then there's no more. Which one's the greatest common factor? 5. Right, so once again, we're looking at which one's the biggest number that is in both. If you guys do it prime factorization, 40, we go 2 times 2 times 2 times 5. 35, we go 5 times 7. So we can see that the greatest common factor is 5. How do you guys do it? Making the list or writing the prime factorization, I really don't care. Right? How do you guys do it? I don't care. Do it one or the other. Right? I'm doing both to show you guys how to do it in both cases, but you do it only one way. And once again, which one of the two you choose, that's totally up to you. You alright? Let's take a look at number 15. Looking at number 15, 27. Let me list all my factors of 27. 1 times 27, 3 times 9, and then that's it. Let me list all my factors of 36. 2 times 18, 3 times 12, 4 times 9, and then 6 times 6. There's all my factors of 36. There's all my factors of 27. Which one's the greatest common factor? 9. Looking if I do a prime factorization, 27 is 3 times 3 times 3. 36 is 2 times 2 times 3 times 3. Multiply your common prime numbers, and that's how you get your greatest common factor. So you guys can see you get it the same way. The greatest common factor I'm looking at, which is the biggest number that I can go into 27 and 36. Greatest common factor. Any questions? Just before I stop, notice I started you guys with 2 numbers only, but look at number 25 and on. I'm giving you guys 3 numbers. But I'm still asking which was the greatest common factor. So in this case, which was the biggest number that goes into all 3 numbers? 30, 35, and 25. 30, 35 goes into all of them. So the way we're going to do this, you guys can make your list. The factors of 30 are 1 and 30, 2 and 15, 3 times 10, and then 5 times 6. Those are all the factors of 30. The factors of 35 are 1 and 35, 5 and 7, and then nothing else. Factors of 25 are 1 and 25, and then 5 times 5. So now, which one is the greatest common factor? 5. And I'm looking at which number is the biggest, but it happens to be in all 3. 5. If we do a prime factorization, 30 is 2 times 3 times 5. 35 is 5 times 7. And then 25 is 5 times 5. They only have a 5 in common. But if they have more than one prime, multiply the primes. That's how you're going to get your greatest common factor. Obviously, I gave you guys a list of 3. I could give you guys 4 numbers. I could give you guys 5 numbers. I could give you as many, and we can still find the greatest common factor. Now, any questions?